All right, today we're talking about how to add and subtract monomials, and then we're going to do a little bit more with multiplying. The difficulty is just up a little bit, and then tomorrow we'll talk about dividing. But the main idea when you're adding or subtracting monomials is only add the blanks aren't quite right. Coefficients. Do not change the variables and the exponents. Okay, what is a coefficient? It's the number in front. So if we had 10x plus 3x, you just look at the 10 and the 3 and call it 13x. You'll be tempted to say x squared because you're like, okay, 1 and 1, they add to 2. That is not how it works when you're adding. That is a shortcut for multiplying powers together, not adding. Okay, so do not change variables and exponents. If, I guess this could be combined like terms, you can only add if they are like terms. Mostly what that has meant so far is same variable, but it now also needs same exponent. Okay, like x squared y cubed cannot add with x cubed y squared. Same letters, different powers. So those could not add together. I don't know if that happens. I don't know if that happens on any of these examples, but something to keep in mind. And all you're doing is just changing how many you have. So on number 1, looking at terms of x, I have 19 and I take away 24 of them. I want to make sure I got the same terms, x and x, so that's good. So now I can just do 19 minus 24 and say negative 5x. Okay. On number 2, you've got an actual power here, a power of 2, so you got to make sure, okay, I've got k, I've got squared, so those match. Now I just can add or subtract. Negative 19 plus 2 is negative 17. I'm not changing what I have. I had k squareds, I added more k squareds, so I still have k squareds. That's all you do. Okay. On number 3, I've got r squared, s cubed, t. That is a match. Now I can just add how many I have. Negative 12 plus 4, negative 8. I don't change how many or what I have, so I just rewrite exactly what it was. R squared, S, 3, T. Okay. Number 4, if there's no number, so I'm trying to figure out how many I have of this a squared b, it counts as 1. Then I check, what do I have? A, b squared. It's a match. So I can do the math. 27 minus 1 is 26. AB squared. Okay, let's do a couple more. I've still got A and A, B and... oh. These don't match. They're not like terms. So what that means is you just rewrite. If there was other things to do in this problem, we'd still do it, but we can't add them, so that is all we can do is just rewrite the problem. Okay. Number 6, I've got C, I've got D. That's a match, so I can add negative 7 plus 6, that would be negative 1, CD. You could also just ignore the 1 and just do negative CD. Doesn't matter. Okay, 2 I guess 4 more. Now, if there is fractions, you should know how to combine these. You have calculators. You could do 2/3 minus 1/4. You could also do it by hand. They need to be common denominators. So thirds and fourths would be twelfths that match. So you'd want to make them twelfths. Want to make sure they match too. X squared, y, and y. Okay, so they do match, so I can do this subtraction. 2/3 minus 1/4. So thirds into twelfths would be 8 twelfths. 1/4 as twelfths would be 3 twelfths. Now I'm just doing the subtraction of 8 twelfths minus 3 twelfths. That would be 5 twelfths. Okay, number 15. M squared, n to the fourth. They match. So I can do the subtraction. Negative 15 minus 15, that does not make 0. You're starting negative and taking away more, so this would be negative 30. M squared, n to the fourth. Okay, got a couple more. Now they're changing the letters. Remember, the letters have to match. So I've got y and y, so those two can go together. And I've got z and z, so those two can go together. When combining them, just look at the symbol that's in front of your second one to know what to do with the numbers you see. So for the y's, I see the minus in front of 11, so I do subtract 11. I'm starting with 2. 2 minus 11. 2 minus 11 is negative 9. And what I subtracted was y's, so it would be negative 9y. For the yellow, I've got z's in front of 10 is a subtraction, so I'm going to subtract 14 minus 10. That would be a positive 4. And since it's a positive answer, I'm writing a plus sign. If it was a negative answer, I'd write a minus sign. Those don't go together and make negative 5. That is all you can do for the subtraction or addition. Last one. Figure out what matches. I've got S and S, so those can go together. 16 minus 17, that would be negative 1s. R has nothing else to combine with, so it doesn't go away, it just doesn't change. It's still plus 8r. Okay, a quick reminder of the product rule. When you are multiplying the terms together, you add their powers. X to the a plus b. Okay, so a quick refresher. We've already done this for quite a few days. X to the fourth times x squared would be x to the sixth, because 2 plus 4 equals 6. 18, I put the 1 there. 4 plus 1 equals 5, so this would be a to the fifth. And then the last one, 5 plus 9 equals 14, so this would be w to the 14th power. Okay, the reason we're covering it again is adding in a little bit more complicated problems like these last 3. But before we cover those, I want to touch on what happens with coefficients. It's the numbers in front. You're still doing a multiplying problem, so you would still multiply numbers normally. So I still just do 3 times 7. That is 21. And then for my variable, I've got x cubed and x squared. 3 plus 2 equals 5, so it would be x to the fifth. For 21, I'm still doing multiplying, so negative 8 times 2 would be negative 16. M to the seventh, m to the third. 7 plus 3 equals 10, so it would be m to the 10th. Last one, looking at what power is there. It's a 1. I'm still multiplying, so I can multiply 9 and 3. That makes 27. For my power of x, 1 plus 7 equals 8, so it would be x to the 8th power. Now, when we move on to multiple letters, you can still only do this product rule with letters that match. So you kind of treat it like 3 different problems. On letters, when there's 3 letters, it's like 4 different problems. But on 23, I'm still multiplying. -6 times 4 be -24. Now, when I move on to A, I only care about the other A. Remember, exponents are repeatedly multiplying the same thing over and over, so I need to only look at when I have the same thing. A and A cubed together, 1 plus 3 would be 4, so I'd have A to the 4th, B to the 2nd power, B to the 6th power. I only would combine them if they're the exact same thing. So 2 plus 6 would be 8, so I'd have B to the 8th power. Okay, 24. This is now 4 separate problems. I've got numbers, I've got some variable P, I've got some variable Q, and I've got some variable R. For the numbers, I've got -2 times -9. That would be +18. For P, I've got 7 of them, and then I'm multiplying 4 more. So 7 plus 4 is 11, so that'd be P to the 11th. For Q, there's 5 of them. I extend the multiplication to 2 more of them. 2 plus 5 equals 7, so that would be Q to the 7th. And then the last one for R, it's a 1st power times a 3rd power, that would be a 4th power. Okay, final question. I'll go kind of quickly through it. 6 and -7 make -42. X to the 5th times x to the 2nd would be x to the 7th. And y to the 8th times y to the 4th would be y to the 12th power. Okay, we'll go back to lessons where I kind of break it up into smaller bits when I'm there. So we kind of had to do 2 things back to back. But you've got a practice worksheet. Complete that, bring your questions on Wednesday, and I'll get you guys answered.